Hi there and welcome to PhD at Living. Last time we talked about a brief history of explosives up to the first synthesis of RDX in 1898. Now we're going to cover the improved synthesis up through World War II and why it was a huge piece that helped the Allies win the war. Let's get going. Henning's original RDX synthesis from 1898 starts with this molecule here called hexamine. It's a common name and I'm not really a big fan of common names, but believe me, you don't want to see the IUPAC name for this thing. 1,3,5,7 tetraazotricyclo-3,3,1,1,3,7 decane. To the hexamine, we add a whole pile of nitric acid, and that backs us into our RDX. This synthesis is also called the Woolwich Process, named after the manufacturing plant in the UK that supported the British war effort with this synthesis. The problem with the Woolwich synthesis is twofold. The first is that in this reaction, water is created. That's bad because diluting your nitric acid makes the nitration effect less powerful. The second is that with that water and the nitric acid, you need a whole bunch of this nitric acid, a gross excess in comparison to the hexamine. And it's an expensive reagent and difficult to reclaim. Another piece is let's look at the atoms in the starting and finishing molecules. RDX has 3 carbons and 3 nitrogens, excluding the nitro groups which we know come from the nitric acid. The hexamine, on the other hand, has 6 carbons and 4 nitrogens. So if we look on a carbon-carbon basis, we could get 2 molecules of RDX, 6 total carbons, from the 6 carbons of our hexamine. On a nitrogen-nitrogen basis, however, we cannot. We need 6 nitrogens in 2 molecules of RDX, and we only have 4 to give. So really, we have 1 nitrogen and 3 carbons that in the Woolwich process just go to waste. So what's a synthetic chemist to do? Let's take a stab at the first problem, our water. Professors at McGill University in Montreal and Penn State University saw that they could take paraformaldehyde, which I'm just going to abbreviate as regular formaldehyde, and ammonium nitrate, NH4, NO3, in the presence of acetic anhydride, which I will also abbreviate AC2O, get hexamine in situ and back all the way over to RDX. The nice part about this is the water that's produced is scavenged by the acetic anhydride. In addition, this process skips the nitric acid entirely and goes straight to RDX without it. When the Ross-Schiessler synthesis came out, people only saw the ingredients, not the conditions of the reaction. This really piqued the interest of a professor at the University of Michigan named Werner Bachmann. Bachmann was involved in the American war effort trying to make RDX better, faster, and more of it. What Bachmann saw is he could take the goods from the Woolwich process and the goods from the Ross-Schiessler mechanism here and combine them to get a hybrid. Bachmann's process, creatively called the Bachmann Process, combines the hexamine and the nitric acid from the Woolwich process and the acetic anhydride and ammonium nitrate from the Ross-Schiessler process to give us this full reaction mechanism. What you'll see here is the ammonium nitrate from the Ross-Schiessler combined with everything else allows us to get from 1 mole or molecule of hexamine 2 moles or molecules of RDX. I can't understate how critical this is. First off, being able to double your synthetic yield in any organic reaction is pretty much like a dream come true. But being able to double your production of RDX for the American war effort? Absolutely gargantuan. Those of you who are cynical enough will probably say that all Bachmann did was combine stuff that other people had already researched, right? Well, Bachmann himself refutes that in a footnote of his seminal article published in the Journal of American Chemical Society in 1949. Says Bachmann, superficially the reaction appears to be a combination of the nitration reaction, read Woolwich, and the procedure of Ross and Schiessler. However, the new reaction would be run under conditions alien to both of the other reactions. It wasn't just that Bachmann found a way to take all 4 of these from other people, he made the synthetic procedure that allowed them to all play nice together and make RDX, and that's a huge amount of work. I guess what I'm really saying is, shut up. And that's the improved synthesis of RDX. 2 moles of RDX out of 1 mole of hexamine via the Bachmann process. An elegant and wonderful piece of chemistry. See you next time. Fulminated mercury and a little tweak of chemistry.